April 6, 1945. Lieutenant Commander Minoru Genda stands on the flight deck of the carrier Amagi, watching 355 aircraft thunder into the sky. They are the first wave of Operation Kikusui, floating chrysanthemums. Every pilot knows this is a one-way mission. Every pilot has written his final letter home. They carry enough fuel to reach the American fleet off Okinawa, but not enough to return. Genda watches them disappear into the eastern horizon and feels something he has not felt in 3 years of war. Not hope, exactly, but certainty. The Americans cannot stop this. No fleet in history has faced massed suicide attacks on this scale. 300 pilots willing to die, each aircraft a guided missile aimed at a carrier or destroyer. The mathematics are simple. Even if the Americans shoot down 90%, an impossible rate, 35 aircraft will strike home. 35,000-pound bombs delivered with perfect accuracy. No fleet can absorb that. By nightfall, Genda will receive the casualty reports. 355 aircraft launched, 342 lost, 13 ships sunk or damaged. The Americans shot down 96% of the attacking force, not 90%, 96. The number makes no sense. It violates everything Japanese naval intelligence understands about anti-aircraft effectiveness. In 1942, when American gunners fired at attacking aircraft, they needed an average of 2,000 shells to achieve a single kill. Now, they're killing with every second or third burst. Something has changed. Genda does not yet know what, but in the wreckage-strewn waters between Kyushu and Okinawa, Japanese pilots are dying faster than their commanders can count, and the weapon responsible weighs less than a kilogram. Fits inside an artillery shell and was dismissed by Japanese intelligence 6 months earlier as technically impossible. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The story begins not in April 1945, but in October 1944. A captured American destroyer, the USS Ward, sits in dry dock at Yokosuka Naval Arsenal. The ship was sunk during the Battle of Leyte Gulf, later salvaged by Japanese forces who wanted to study American damage control and electronics. Captain Yoshio Kodama, chief of the Navy Technical Bureau's Weapons Analysis Section, leads the inspection team. In the destroyer's forward magazine, they find something unusual: artillery shells with an odd bulge at the nose. Not the standard pointed tip of armor-piercing rounds or the blunt nose of high-explosive shells. These have a small cylindrical protrusion, about 3 centimeters in diameter, that looks almost like a miniature radio antenna. Because that is exactly what it is. Kodama orders the shells transported to the laboratory. His team disassembles one carefully, cutting through the steel casing with precision saws. Inside, they find something that should not exist: 5 miniature vacuum tubes, each no larger than a man's thumb, dozens of capacitors and resistors, each smaller than a grain of rice, coils of wire wound so finely they require a microscope to examine, a battery that activates on firing, a detonator wired to electronic circuitry. The senior engineer on Kodama's team, a man named Tanaka, who studied electrical engineering at Tokyo Imperial University, stares at the components for a long time. Then he says quietly, "This is a radio transmitter and receiver inside an artillery shell." The room falls silent. Everyone understands the implication. If the Americans have placed a working radio inside a shell that survives the 15,000 G-forces of being fired from a gun, if they have miniaturized electronics to this degree, if they have solved the problems of spin stabilization and centrifugal force and shock resistance, then the technical gap between American and Japanese industry is far wider than anyone admitted. Tanaka measures the vacuum tubes. They are 1/3 the size of comparable Japanese tubes. The capacitors use materials Japan cannot manufacture at scale. The assembly precision suggests tooling and quality control beyond anything in Japanese factories. He writes in his preliminary report, "The component miniaturization indicates manufacturing capabilities approximately 10 to 15 years ahead of our current industrial capacity." But the truly disturbing question is not how the Americans built this device. The question is what it does. Tanaka reconstructs the circuit. A transmitter emits radio pulses forward. The pulses reflect off any metal object, an aircraft, and return to the receiver. When the reflected signal reaches a certain strength, meaning the target is close, the circuit triggers the detonator. The shell explodes without any timing mechanism, without any guess about the target's altitude or speed. It simply waits until it detects something nearby, then fires. Kodama reads the report and immediately grasps the tactical implications. Every anti-aircraft shell Japan fires uses a timed fuse. Gunners must estimate the target's distance, speed, and course, then set a fuse to explode at a calculated altitude. The margin for error is enormous. Wind affects trajectory. Pilots maneuver. Distances are misjudged. Out of 100 shells fired, perhaps 3 explode close enough to damage an aircraft. But a shell that detonates itself when near a target requires no calculation, no guesswork. It simply works. Fire it in the general direction of an enemy aircraft, and when it passes close enough, it explodes. The effectiveness increase would be, Kodama does the mathematics, perhaps 4 or 5 times higher than conventional shells. He writes an urgent report to the Naval General Staff. The Americans possess a proximity-detonated artillery shell using miniature radar. Production appears to be serial, not experimental. Recommend immediate investigation into deployment scale and countermeasures. The report is marked top secret and forwarded to Admiral Toyoda, Commander-in-Chief of the Combined Fleet. Toyoda reads it and sets it aside. The assessment seems exaggerated. Yes, the Americans have advanced electronics. Yes, their miniaturization is impressive. But mass-producing such a complex device is another matter entirely. The report itself notes that each shell contains 75 separate components, each requiring microscopic assembly. No nation could manufacture such things by the thousands. Perhaps the Americans have a few hundred for testing. Perhaps they equip a single destroyer squadron as an experiment. But widespread deployment is impossible. The technology is too complex, too expensive, too difficult to manufacture at scale. This is the mistake. This is the belief that will kill thousands of Japanese pilots over the next 6 months. The assumption that because something is difficult, the Americans cannot do it in quantity. The failure to understand that American industrial capacity operates on a scale Japan has never imagined. In fact, by October 1944, when Kodama's team examines their first proximity fuse, American factories have already produced 11 million of them. Western Electric alone manufactures 40,000 per day. The Buffalo plant operates 3 shifts. Women who 6 months earlier assembled telephone switches now solder circuits inside artillery shells under microscopes. The failure rate has dropped from 30% to 11%. The fuses work. They work reliably, and they are being loaded onto every destroyer, every cruiser, every battleship in the Pacific Fleet. The Japanese do not know this, cannot know this. The scale is too large to believe. So they believe what seems reasonable, that the Americans have a clever prototype, perhaps a few thousand rounds for special operations, but nothing that will fundamentally alter the tactical balance. This belief will carry forward through the winter of 1944 into the spring of 1945, when Operation Kikusui begins and the killing starts. January 1945. The Naval General Staff approves the kamikaze strategy. The logic is brutal but clear. Japan has approximately 10,000 aircraft remaining, not enough to contest American air superiority in conventional combat. But if every aircraft becomes a guided missile, if every pilot accepts death as the mission, then 10,000 aircraft become 10,000 precision-guided weapons. Even a 5% hit rate, optimistic but possible, yields 500 ships sunk or damaged. Enough to make an invasion of the home islands too costly. Enough, perhaps, to force a negotiated peace. The plan depends on overwhelming the enemy's defenses. The Americans can shoot down individual aircraft Easily, their fighters are faster, their pilots better trained, their radar gives them warning. But no defense can stop 300 aircraft attacking simultaneously from multiple directions. Some will die on approach. Many will die, but enough will get through. The mathematics are favorable. What the planners do not account for is that American mathematics have changed, that the old calculations of anti-aircraft effectiveness no longer apply, that a technological breakthrough has multiplied defensive firepower by a factor the Japanese cannot imagine because they do not believe such multiplication is possible. February 19th, 1945. The first large-scale test comes at Iwo Jima. 50 kamikaze aircraft attack the American fleet supporting the Marine landing. The carriers launch fighters. Most of the Japanese aircraft die before reaching the fleet. But 9 break through the fighter screen and begin their final dives toward the destroyers and transports. The destroyer Benion tracks them on radar. The gun crews train their 5-inch guns skyward. Load proximity fuse. The executive officer, Lieutenant Commander John Walsh, has been briefed on the new ammunition. He knows it is classified. He knows it is supposed to be effective. He does not know how effective, because the Navy has not released combat statistics to individual ship commanders. Operational security demands silence. So, Walsh watches and waits as 9 Japanese aircraft begin their death dives, wondering if the miracle shells will actually work. The first kamikaze, a Zero fighter loaded with a 250-kilogram bomb, dives from 3,000 meters. The forward gun mount tracks it. One shot. The shell explodes 8 meters in front of the aircraft. The Zero disintegrates. Fragments rain into the sea. The gun crew stares. They have never seen a kill on the first shot. Never. The second kamikaze comes from a different angle. Starboard side. Low altitude, trying to evade radar. 2 shots. Both explode near the target. The aircraft breaks apart 700 meters from the ship. The third kamikaze gets closer. The pilot is skilled or lucky or both. He jinks left and right, changing altitude, making himself difficult to track. 4 shots. 3 explode near him. The 4th hits directly. The aircraft vanishes in an orange fireball. In 7 minutes, Benion engages 6 kamikaze aircraft, expends 43 proximity-fused shells, shoots down all 6. Not a single aircraft reaches attack range. Walsh writes in his after-action report, "The effectiveness of VT fuse exceeds all expectations. Recommend maximum deployment to all fleet units." But the report is classified. The data is collected, analyzed, filed. Individual ship commanders are not told the overall statistics because if they were told, and if any were captured, the Japanese would learn the truth, that kamikaze tactics are obsolete before they begin, that the Americans possess a defensive technology which makes mass air attack suicidal in the most literal sense. March 1945. Intelligence reports filter back to Tokyo. The kamikaze units launched against American forces at Iwo Jima achieved a lower than expected hit rate. Out of 223 aircraft committed, 14 scored hits on American ships, 6%. Casualties were acceptable. All pilots killed, as expected. But effectiveness was below projections. The Naval General Staff reviews the data and concludes the pilots need better training in evasive maneuvers and final approach techniques. No one suggests the Americans have fundamentally changed the defensive equation. No one wants to suggest it. Because if American anti-aircraft effectiveness has increased by a factor of 5 or 6, then the entire kamikaze strategy collapses. 10,000 aircraft sacrificed for perhaps 600 hits, not the projected 3,000. And 600 hits might not be enough. The staff officers choose to believe the Iwo Jima results were an anomaly. Bad weather, bad luck, bad tactics, correctable problems. The kamikaze training intensifies. Pilots practice low-altitude approaches. They drill on jinking maneuvers. They study American ship formations and plan multi-directional attacks designed to overwhelm defenses. Everything is optimized except the one variable that matters. The Americans are shooting 5 times better than they were 6 months ago. And the improvement is not training or tactics. It is technology. Japan dismissed as impossible. April 1st, 1945. Operation Iceberg begins. The American invasion of Okinawa. 180,000 troops land on beaches 350 miles from the Japanese home islands. Admiral Raymond Spruance commands 550 warships, including 18 fleet carriers, 18 battleships, and 240 destroyers. It is the largest amphibious assault in the Pacific War, and it is the target of Japan's most desperate gamble. The Naval General Staff activates Operation Kikusui, 10 massed kamikaze waves, each between 100 and 300 aircraft, timed over 8 weeks to coincide with American vulnerability during landing operations. The first wave launches on April 6th. 355 aircraft, the largest single kamikaze attack of the war. Pilots receive final instructions from their commanders. Aim for carriers if possible. Any large ship, if not. Do not abort. Do not return. You are already dead. Die with honor. They take off from airfields across Kyushu in the early morning. The formation is too large to maintain cohesion. They fly in loose groups, following lead navigators toward the coordinates where American radar picket destroyers wait 80 kilometers north of Okinawa. The Americans call these ships sitting ducks, destroyers stationed far forward to provide early warning, deliberately exposed, sacrificed, to buy time for the main fleet to prepare defenses. The first group of kamikaze encounters Destroyer Division 48 at 1100 hours. 4 destroyers. Bush, Calhoun, Colhoun, and Cassin Young. 16 5-inch guns between them. Each gun loaded with proximity-fused shells. The destroyer's radars pick up the incoming aircraft at 25 kilometers. The gun directors calculate firing solutions. The crews train their weapons skyward, and then the killing begins. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The first kamikaze dies at 18 kilometers. One shot. The shell explodes directly beneath the aircraft. The pilot never sees it coming. Just a flash, a shock wave, fragments tearing through aluminum and flesh, and the Zero tumbles into the sea, trailing smoke. The second kamikaze dies at 16 kilometers. 2 shots. The third dies at 14 kilometers. 4 shots, but 3 proximity detonations so close together they create a continuous curtain of shrapnel. Bush's gunnery officer, Lieutenant Eugene Barham, watches through binoculars. He has been in the Pacific for 18 months. He has fired thousands of anti-aircraft rounds. He has seen Japanese aircraft shot down, but never like this. Every burst is a kill or near kill. The proximity fuses are functioning with mechanical precision. The shells explode exactly when they should, exactly where they should. It is almost beautiful, if you can forget what it means. 12 kamikaze aircraft attack Bush in the first wave. The destroyer's guns fire 317 shells in 22 minutes. 11 aircraft are destroyed on approach. The 12th breaks through. The pilot is either supremely skilled or impossibly lucky. He comes in low, below the effective angle of the forward guns, jinking left and right, engines screaming. The aft gun mount tracks him. 3 shots, all proximity kills, but too far to destroy the aircraft. The Zero is damaged, trailing smoke, but still flying. Still coming. It hits Bush amidships. The 250-kilogram bomb detonates inside the hull. The explosion ruptures steam lines, ignites fuel stores, kills 38 sailors instantly. Bush lists to port. Dead in the water, Calhoun moves to assist, and then the second wave arrives. 47 more kamikaze, fresh pilots who watched the first group die and kept coming anyway. Bush cannot maneuver, cannot escape. The gun crews keep firing. They expend every proximity-fused shell in the magazines, switch to standard ammunition, keep firing. 7 more kamikaze hit Bush. The destroyer breaks in half and sinks in 18 minutes. 94 sailors die. But consider the mathematics. 59 kamikaze aircraft attacked 4 destroyers in 40 minutes. 51 were shot down on approach. 8 broke through. Of those 8, 5 hit targets, 3 achieved kills. The success rate was 5%. Before proximity fuses, that rate would have been 20 to 30%, perhaps higher. The Americans would have lost all 4 destroyers, not just Bush. The casualties would have been 400 sailors instead of 94. The technology saved 3 ships and 300 lives in a single engagement, and this was just the first day of Operation Kikusui. 9 more waves were coming. April 7th, 1945. Tokyo. The Naval General Staff receives preliminary reports from the first Kikusui wave. The numbers are delivered by courier, decoded, and placed on Admiral Toyoda's desk. 355 aircraft launched, 342 confirmed lost, 13 ships reported sunk or damaged by returning scout aircraft. Toyoda reads the figures twice. The loss rate is acceptable. All kamikaze missions assume total pilot casualties, but the hit rate troubles him. 13 ships from 355 aircraft, less than 4%. The pre-operation estimates projected 10 to 15%. The discrepancy is significant. He asks his staff for an explanation. The answers come quickly, perhaps too quickly. Poor weather, reduced visibility. American fighter interception was heavier than expected. Some pilots likely became disoriented and crashed into the sea before reaching targets. Pilot inexperience. Many were recent graduates with fewer than 50 flight hours. All plausible, all comforting, all wrong. What Toyoda does not see, what no one in Tokyo sees, are the engagement reports from American destroyer captains. Reports that describe kamikaze aircraft being destroyed at ranges exceeding 10 kilometers. Reports that document shell expenditure ratios of 30 rounds per kill, sometimes fewer. Reports that use the phrase VT fuse repeatedly, though the term means nothing to Japanese intelligence because they have never encountered it before. The Americans are careful. Every report mentioning proximity fuses is classified, secret, or above. Captains are instructed to use coded terminology in radio transmissions, special ammunition, or new issue rounds, but never technical details. The classification system works. Japanese radio intelligence intercepts hundreds of American transmissions during and after the April 6th attack. They hear references to ammunition effectiveness. They hear gunnery officers congratulating their crews, but they hear nothing that explains why the effectiveness has changed. Captain Kodama, the naval engineer who first examined proximity fuses 6 months earlier, requests access to the Kikusui casualty data. He is troubled by something he cannot quite articulate. The American shells he studied in October suggested a capability that would revolutionize anti-aircraft warfare. But his report was filed, acknowledged, forgotten. Now, watching the casualty figures from Okinawa, he wonders if his warning was ignored. He writes a second report, more urgent than the first. The anomalous effectiveness of American anti-aircraft fire suggests possible deployment of proximity detonated shells on a wider scale than previously assessed. Recommend immediate tactical countermeasures, including low-altitude approach profiles below 50 meters to minimize radar reflection and increase detonation errors caused by ground proximity. This report reaches Admiral Matome Ugaki, commander of the 5th Air Fleet, responsible for kamikaze operations in Kyushu. Ugaki reads it and makes a decision. The next wave will fly lower, below 100 meters during approach, dropping to 30 meters for the final attack run. Proximity fuses, if that is indeed what the Americans are using, cannot function reliably that close to the ocean surface. The radar reflections from the water will confuse the circuits. The shells will detonate too early or not at all. It is good tactical thinking. It is also 6 months too late. The Americans already encountered this problem in late 1944 when kamikaze pilots began using low-altitude attacks. The engineers in Baltimore redesigned the fuse sensitivity circuit, adding filters to distinguish between static ocean surface and moving aircraft. The updated fuses reached the fleet in January 1945. By April, nearly every ship in the Okinawa Task Force carries the improved model. April 12, 1945. The second Kikusui wave, 185 aircraft. They follow Ugaki's instructions, approaching at wave-top level. The American radar picket destroyers detect them at reduced range, 12 to 15 kilometers instead of 25, but detect them nonetheless. The destroyers open fire. The low-altitude approach helps. Some proximity fuses do detonate prematurely, confused by sea return. But the improved circuits function on most rounds. The kamikazes still die, just slightly closer to their targets than before. The destroyer Manat El Abele engages 9 aircraft, shoots down 6. The 7th and 8th breakthrough. One is a conventional Zero. The other is something new. An Oka, cherry blossom. A manned, rocket-propelled bomb carried beneath a Betty bomber and released 12 kilometers from target. The Oka pilot ignites his rocket motor and accelerates to 900 kilometers per hour. It is too small and too fast for proximity fuses to track effectively. The reaction time is insufficient. The Oka strikes a belay below the waterline. The destroyer breaks in half and sinks in 5 minutes. 79 sailors die. It is the first and essentially only successful Oka attack of the war. The Japanese built 850 Oka bombs. Fewer than 60 were ever launched in combat because the slow Betty bombers carrying them were shot down before reaching release range. But this one success proves something important. Proximity fuses are not magic. They can be defeated by sufficient speed or by attacking from unexpected angles. The technology has limits, but those limits do not matter if you cannot exploit them. The Oka requires a bomber to carry it within 12 kilometers of the target. Most Betty bombers die long before reaching that range, killed by American fighters or by the same proximity-fused shells that protect the ships. Producing 850 Oka accomplishes nothing if only 60 can be delivered to their targets. It is another case of Japanese engineering excellence meeting American industrial scale and losing. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. April 16th, third wave, 165 aircraft, casualties 151, hit rate less than 5%. The pattern is now undeniable. Something has changed in American defensive capability. The Naval General Staff can no longer blame weather or tactics or pilot inexperience. The Americans are shooting down kamikaze aircraft at rates that defy every historical precedent. Ugaki receives a classified intelligence summary from the Army, a Wehrmacht technical report smuggled through neutral channels describing a new Allied artillery shell that uses radar to determine detonation altitude. The report is 9 months old, captured during the Battle of the Bulge, but the Japanese only now obtained a translation. Ugaki reads it carefully. The description matches what Kodama warned about in October: proximity fuse, radio transmitter and receiver, automatic detonation. The report includes a German assessment of countermeasures. Electronic jamming was attempted. Results were mixed. Some shells detonated prematurely, but many functioned normally. The fuses operate across a range of frequencies, making broad-spectrum jamming impractical. Physical shielding is impossible for aircraft. The only reliable counter is to avoid the shells entirely, which means avoiding American ships, which defeats the purpose of attacking them. Ugaki closes the file and sits in silence for a long time. He has sent 3 waves against the Americans. More than 700 aircraft, 700 pilots, most of them teenagers with barely sufficient training to take off and land, convinced they would die honorably and sink American carriers in the process. The casualties were expected. The failure was not. Fewer than 30 ships hit, perhaps 10 actually sunk. A hit rate of 4% against a projected 15. He does the mathematics. 7 more waves are planned, approximately 1,500 more aircraft. If current effectiveness holds, they will score 60 more hits. Optimistically, 20 ships sunk against a fleet of 550 vessels. This is militarily insignificant. The Americans can absorb these losses without operational impact. Meanwhile, Japan will have expended nearly all remaining air power. on an attack that fails to achieve strategic objectives. But there is no alternative. Surrender is unthinkable. Conventional defense is impossible. American material superiority makes any battle of attrition suicidal. The kamikaze strategy, flawed as it is, remains the only option that offers even theoretical hope of success. So the attacks continue, wave after wave, pilot after pilot, each one briefed, each one convinced his death will matter, each one launching into skies increasingly dominated by American technology they cannot counter. May 4th, fifth wave, 125 aircraft. The destroyer Loose engages 14, shoots down 11 with proximity-fused shells, the 12th and 13th breakthrough in a coordinated attack from opposite sides, overwhelming the gun director's ability to track multiple targets. Both hit. Loose sinks, 149 sailors die, but the mathematics remain brutal for Japan. 14 aircraft attack, 2 achieve hits, 12 die for nothing. May 11th, sixth wave, 150 aircraft. Among them, Lieutenant Haruo Araki, the 19-year-old pilot whose diary would later be recovered and published. His final entry, written the night before the mission, reveals an understanding his commanders either lack or refuse to acknowledge. We know the Americans have new shells. They explode in the air. The seniors say you cannot get close. The sky becomes a wall of fire. But we must go. The Emperor awaits our sacrifice. If I am lucky, I will touch the enemy ship. If not, I will accept death in the air. Duty fulfilled. Araki does not return. American records indicate he was shot down 3 kilometers from the carrier Bunker Hill. A proximity-fused shell exploded 7 meters beneath his zero. The fragments shredded the aircraft's belly. It tumbled into the sea. He was given no opportunity to die in collision with the enemy. The technology denied him even that final honor. But some get through. The carrier Bunker Hill is hit twice in 3 minutes by kamikaze aircraft that evade the defensive fire through a combination of skill and concentration of attack. 396 sailors die. The carrier survives, but is knocked out of action for the remainder of the war. The Japanese propaganda machine seizes on this success. Radio broadcasts proclaim the divine wind is working. American losses are mounting. Victory is near. The reality is different. Bunker Hill is 1 carrier damaged among 18 operational in the task force. The attack cost 23 aircraft, 23 pilots for 1 carrier damaged. The exchange ratio is catastrophic, but Tokyo does not calculate exchange ratios anymore, cannot afford to. The strategy requires faith, not mathematics. Faith that enough aircraft, enough pilots, enough deaths will eventually overwhelm American defenses through sheer accumulated damage. May 24th, 7th wave, 165 aircraft. By now, the kamikaze pilots understand what awaits them. They have seen the previous waves depart. They have waited for aircraft that do not return. They know the survival rate is 0. That much was always expected. But increasingly, they suspect the hit rate is also approaching 0, that they will die without achieving anything, that their sacrifice is tactically meaningless. Some refuse to fly. Not many. Perhaps 24 across all of May. They are not executed. The military understands that forcing a man into a suicide mission defeats its psychological purpose. Instead, they are reassigned to ground duties, quietly removed from flight status, forgotten. Their families are told they died honorably. The shame is buried in paperwork. But most fly. Most accept the mission because accepting is easier than refusing, because their culture provides no vocabulary for refusing, because saying no to the emperor is unthinkable, even when saying yes means death without purpose. They climb into their cockpits. They take off. They fly toward Okinawa, and the American guns kill them at ranges where they cannot even see the ships they are meant to destroy. The destroyer Hugh W. Hadley engages 26 kamikaze aircraft on May 24th, expends 973 proximity-fused shells, shoots down 23 aircraft. 3 break through the defensive fire. 1 hits. Hadley survives, barely, with 29 sailors dead. The ship's executive officer writes in his report, "The VT fuse is the only reason we are still afloat. Without it, we would have been hit 6 or 8 times instead of once. Every ship in the picket line owes its survival to this ammunition." The report is classified, filed, never shared with the Japanese, who continue attacking with tactics designed for a defensive environment that no longer exists. They are fighting the war of 1943 with strategies calibrated for anti-aircraft effectiveness rates that were obsolete by mid-1944. The temporal lag is deadly. By the time Japanese intelligence fully understands what the Americans deployed, the war is effectively over. June 3rd, 8th wave, 110 aircraft. Ugaki no longer writes optimistic assessments. His diary entries become terse, factual, drained of enthusiasm. Today's attack achieved minimal results, losses total, effectiveness below projections, enemy defenses remain formidable. He does not mention proximity, fuses, directly. Operational security forbids it. But the implication is clear to anyone reading between the lines. June 21st, 10th and final wave, 45 aircraft. It is a small wave, almost an afterthought. Japan has expended most of its remaining air power. The pilots are barely trained. Some have fewer than 20 flight hours. They can take off and fly straight. Whether they can hit a maneuvering ship is doubtful. Whether they can even find the American fleet is uncertain. They find it. The picket destroyers shoot down 38 before they reach attack. Range, 7 breakthrough. 2 hit ships, both targets survive. 45 pilots die. 2 ships damaged. The exchange is grotesque, but it is over. Operation Kikusui is complete. The divine wind has blown itself out. The final accounting: 10 waves, approximately 1,465 aircraft committed, 1,412 lost, 96% casualties, 36 American ships sunk, 368 damaged, approximately 5,000 American sailors killed, 4,000 wounded. These are heavy losses, the highest ship casualties the US Navy suffered in any single operation of the war. But against a fleet of 550 vessels, the damage is absorbable. The Americans continue landing operations on Okinawa without interruption. The supplies keep flowing. The air support continues. Tactically, strategically, Operation Kikusui fails. It inflicts pain, but not paralysis. Damage, but not defeat. And the reason, not the only reason, but the crucial force multiplier, is a device weighing 800 grams that Japanese intelligence dismissed as too complex for mass production. The proximity fuse did not win the Battle of Okinawa alone. American fighters shot down hundreds of kamikaze. American damage control saved dozens of hit ships. American logistics ensured every loss was quickly replaced. But the proximity fuse was the defensive backbone, the technology that turned kamikaze tactics from dangerous to suicidal, from effective to futile. After the war, Admiral Ugaki's diary was recovered from the wreckage of his final flight. He died in a kamikaze attack on August 15, 1945, hours after Japan's surrender was announced. In his last entries, he reflected on Operation Kikusui. One passage stands out: "We threw our pilots against a wall we could not see, a wall made not of steel, but of mathematics. Every calculation we made assumed the enemy's weapons functioned as our weapons functioned. We assumed parity where none existed. We assumed our spirit could overcome their material advantage. We were wrong. Not about spirit. Our pilots died bravely, honorably, but brave men die just as easily to smart weapons as to crude ones. Perhaps more easily, because they do not flinch, do not evade, do not abandon the attack even when survival is impossible. The Americans built a better shell. That should not decide wars, but it did. July 1945. With Okinawa secured and the kamikaze threat largely neutralized, American strategists begin planning Operation Downfall, the invasion of the Japanese home islands. Intelligence estimates Project Fierce Resistance. 10,000 additional kamikaze aircraft are believed to be hidden across Kyushu and Honshu. The casualties are projected in the hundreds of thousands, but the planners also know that those 10,000 aircraft will face the same defensive technology that destroyed 96% of the kamikaze at Okinawa. Proximity fuses are now standard issue across the entire Pacific Fleet. Production has reached 60,000 units per day. American destroyers carry magazines full of them. The shells that Japan dismissed as impossible are now so common that ships expend them freely without rationing, confident that more will arrive on the next supply ship. In early August, the atomic bombs are dropped. Japan surrenders. Operation Downfall is never executed. The 10,000 kamikaze never fly. Whether proximity fuses would have maintained their effectiveness against a defense of the home islands remains unknown. Perhaps Japanese tactics would have evolved. Perhaps concentration of aircraft would have overwhelmed even the improved defenses. Perhaps, but what is known, what the statistics demonstrate beyond dispute, is that a weapon Japan's technical experts declared too sophisticated for mass production was manufactured by the millions. That a technology dismissed as experimental was deployed fleet-wide within 18 months of its combat debut. That American industrial capacity once again operated at a scale Japanese planners could not imagine and therefore could not counter. The proximity fuse saved an estimated 10,000 to 15,000 American sailors' lives during the Okinawa campaign. It reduced ship losses by 30 to 40% compared to projected casualties using conventional anti-aircraft ammunition. It transformed the kamikaze from a potentially war-winning tactic into a tragic waste of pilots who died bravely but uselessly, killed by technology their commanders insisted could not exist. Years later, in 1952, Captain Kodama, the engineer who first examined the proximity fuse in October 1944, was interviewed by American military historians compiling a technical history of the Pacific War. They asked him why Japanese intelligence failed to recognize the threat earlier, why countermeasures were not developed, why the warnings were ignored. Kodama was silent for a long time. Then he said, "Could not believe you would do it, could not. We understood the principle, understood the engineering challenges, but we could not believe you would solve those challenges and then manufacture the solution by the millions. That level of industrial commitment to a single weapons system seemed irrational. A proximity fuse costs what? $18. A skilled pilot cost perhaps $5,000 to train. You spent billions on a weapon to kill pilots who cost thousands. The mathematics seemed wrong." He paused. "But your mathematics were different. You calculated the cost of losing ships, losing sailors, prolonging the war. You calculated the strategic value of technological superiority. We calculated the cost of production. You calculated the cost of not producing. Your mathematics were correct. Ours killed our pilots." The interviewer asked whether Japan attempted to develop its own proximity fuse. Kodama smiled sadly. "We tried. Late 1944, after my first report, a small team, maybe 20 engineers. By March 1945, we had a prototype. It was bulky, unreliable, failed 4 times out of 10. To make it work consistently would require another year. To manufacture it at scale would require factories we did not have, materials we did not possess, precision tooling we could not build. We were trying to copy in months what took you 3 years and $2 billion. We failed because we started too late and lacked the industrial base to succeed even if we had started earlier." The proximity fuse's impact extended beyond Okinawa, beyond the Pacific War, beyond World War II itself. It represented a philosophical shift in weapons development, that complexity and reliability were not mutually exclusive, that sophisticated technology could be mass-produced if sufficient resources were committed, that defensive weapons could be as revolutionary as offensive ones. Modern air defense systems, Patriot, Aegis, Iron Dome, are descendants of the same concept: detect, calculate, detonate. without human intervention. The VT fuse was the first step. There is a memorial in Yasukuni Shrine in Tokyo honoring the kamikaze pilots of Operation Kikusui. 1,412 names are inscribed. The memorial text speaks of courage, sacrifice, dedication to duty. It does not mention that most of these pilots died not in collision with enemy ships, but in the air, miles from their targets, killed by shells their commanders insisted were technologically impossible. In 1995, on the 50th anniversary of the battle, a joint American-Japanese naval ceremony was held off Okinawa. Veterans from both sides attended. An American destroyer captain who had commanded a picket ship during Kikusui met a Japanese pilot who had flown in the sixth wave and survived only because his aircraft developed engine trouble and he was forced to return to base. They spoke through an interpreter. The American mentioned the proximity fuses, explained how they worked, described their effectiveness. The Japanese pilot listened and then said, very quietly, "We knew. By May, we knew something had changed. We could see the shells exploding perfectly surrounding us. We called them the ghost shells because they seemed to know where we were before we arrived. Many pilots said the Americans had developed a new type of divine wind, one that protected them instead of us. We joked about it. But we knew the truth. It was not divine. It was engineering." The destroyer captain asked, "Would you have still flown if you had known, truly known, how effective they were?" The pilot thought for a long time. "Yes," he said finally, "because not flying was not an option. Our culture, our training, our oaths. We could not refuse. But I think we would have understood better what we were dying for. Not for victory. Victory was already impossible. We were dying to delay the inevitable, to buy time for a surrender on slightly better terms. The ghost shells made that clear. But we flew anyway. What else could we do?" Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.